Hello everyone, welcome to this lecture. In this lecture, I will talk about debugging and exceptions. Before that, as a reminder, I will release assignment 6 tomorrow, and the deadline for assignment 6 is the next Tuesday as a final assignment for this course. And for this assignment, you need to submit a code for the question 2 and a PDF for the question 1. And for the final step of your project, you need to post a 3 or 5 minutes video on Piazza, and also submit a one-page report as a summary for your project to assignment 6 reader. And for the last 5 weeks, you did a bit of a small part of your project in each assignment. And I will expect that you're now able to load your data set and create a visualization and also build a model or fit a model on your data. So as a summary, you need to submit a PDF on Gradescope, 1 page, just explaining the data set and some visualization of your features, and then if you fit a model on your data, you can explain that and then report the results for 1 page. And also you need to record a 3 or 5 minutes video and then post on Piazza. You can do that public. You can set it to public, to be public or private if you are not comfortable to share it publicly. And also for the recording the video, you can use any tools or softwares that you want. But I will explain how we can do that on Zoom and YouTube. So if you want to record your video on Zoom, you just need to open this link, and then there's another link for the host. And after clicking on the host, you can find the record button, and also another one, which is the share screen. You can click on the record button and or share screen in either way you want, and try to record your video. And after doing that, you just need to click on stop share button and end button. And when you click on the end, the Zoom start processing your data, your video, and then save it as a MP4 file in this directory, document/zoom/ a weird name for your video. So you can just directly attaching this MP4 file on Piazza Post, or if you prefer, you can upload your video on YouTube and share a link with us. So how we can upload on YouTube? You just need to create an account and sign in, and then I think in the right corner on top of your screen, there's a camera icon that you need to click on that to open another window that you just need to select your MP file for, and then upload your file. And then I think there is an option to say that this is the video for the kids or not, and you just need to select no, it's not made for kids. And you need to hit next twice and then select unlisted. And after doing that, you just need to copy the link and then paste the link in a Piazza post. So In this lecture, I will talk about debugging, and actually debugging is a process finding the bugs in your code. The bugs are errors that happen in your code. And this process can take as much or more time as writing the code itself. And if you can define the bug and solve it, you can save lots of your time. So having the skill to finding the bug and solving it's so important in the programming. So most of the programming language have tools for debugging. They called the debuggers, and for the Python I mentioned 4 of them here. The first one is the PDB, which is the built-in debugger. The other 3 are graphical debuggers, for example, Spider, which we know is a IDE for the programming in Python, has a built-in debugger. And I will show some example from the PDB, and you can also find debuggers in the Spider or DDD and PUDB, which are graphical debugger. There's a general definition for the debugging, and actually it's a principle of the confirmation. Fixing a buggy program is a process of confirming one by one that the many things you believe to be true about the code actually are true. So we have lots of line of code, and we believe that all of them are correctly working together. But when you find that one of your assumption about just one line or 10 line or doesn't matter, is part of your code is not true, you have find a clue to the location of the bug. So in other words, we are looking for things that we don't expect. So you want to find a part of your codes that generate the bug, and then try to solve the bug or solve the error in your program. So there is 2 steps for debugging, and they are so important to consider. The first step is that you need to locate the bug. This means that before trying to find out what is the wrong with your code, at the first step, you need to just find the location of your program that generate the bug or error. And after that, you need to understand the bug. So a very common mistake made by new programming is try to and figure out what is the wrong with the code. And actually, it's matter, but at the first, you need to find the location of the bug instead of finding what is the wrong with the code. And if you find the location of the bug, that can be much easier to understand the bug and then try to solve that. And there are 2 types of bugs that we consider here. The first one is the syntax versus semantics. And maybe you already know that, but if you have some rules for writing code in a program in a language, for example Python, and if you are not following these rules, you will get a syntax error. For example, in for loops, at the end of the line, you should have a colon, right? So if you don't put a colon at the end of the for loop statement, you will get an invalid syntax. There is another type of syntax error that I mentioned here, but generally syntax error means that you are not following the rules that we are we have in the language. And this type of error always cause your program to crash and are usually easy to find. And another type is the semantic error that this type of error happen when the code is valid but does not do what you expected. So this means that the syntax of your code is true and is correct, but you have some logic in your code that is not valid. For example, you cannot assign a, a, a boolean with the false value to a boolean to another boolean to true value, and also that can happen with lots of other semantic errors. For example, you expect that a value for one variable is not greater than 20. And after running your program, you find out that the value of these variables is 100. In this case, there's a bug in your code, and you should find that. And there's no syntax error in your code, but there is a semantic error. And also these type of error are much hard, finding them are much harder than the syntax error. And we can divide the bugs in debugging into two other categories that are deterministic and non-deterministic. And for deterministic bug, this type of bug appear every time the same input is used. Means that your code generate a bug when the input, for example, is 1. But if you change the input to 2, you are not getting the same error. So every time the input is the 1, you are getting the same error. This means that there is a deterministic bug in your code. And I should mention that this is the most common bugs compared to non-deterministic one. And this also is hard to find because you are not getting the same error for every input. Sometimes you are getting that, and you should be able to run your code with all possible values of the inputs to find that your code is not generating an error. And that makes it hard to find this kind of bug in your program. Another one is the non-deterministic bug, which appears irregularly. And as if I want to mention an example of this, consider that you have a code that is based on randomness. And sometimes you are getting a bug, or your program can have a bug with some random numbers, but with other random numbers, you are not getting the same error. In this case, which means that your code is generating a non-deterministic bug. And other example can be found in a non-deterministic bug, which is the parallel code with race condition, which means that there are some condition. If this condition is true, we are getting an error, and if the condition is not true, we are not getting that. And also codes that relies on exterior state, which means that, for example, our code getting the temperature of the room, and based on the value of the temperature of the room, we are getting we are finding like a bug in our program. But this means that the code is just based on some variables that are not defined in the code. So a common method for finding the bug in the programming is printing the variables at the intermediate state. So this means that we are printing these values to these variables to find the their values, and based on the values that they have, and we are trying to find the bug. But actually, we shouldn't do that because there's a general rule for debugging in the programming is that you shouldn't modify your code in order to debug it. This means that if you are trying to find a bug in your code and change some variables to see the value of them or find the bug, this means that you're changing the code and maybe this code doesn't generate the same bug, and you will lose clues to location of the bug. So I think there is a general rule that you shouldn't modify your code if you are debugging your code. So instead of this, we can use many debugging tools. I want to mention one of them here, which is the PDB. And if you want to use PDB, you can just write this line of the code in your command line, which is the Python -m, and then the keyword PDB, and the name of the script that you want to debug, right? So after writing this line of the code, you will get the location of the script that you are debugging, and then the first line of the code in your script. There are some actually there are some yeah, there are some other yeah, I'm not sure if this is the first line, or I think that because at the top of the script we are we are actually importing some module. This means that this is the first line of the code, but I'm not sure this if this actually PDB run the line of the first line of the script or not. But there are some other line of code that we can use in BDB to control the debugging process. The first one is breakpoints that actually the breakpoints are the location that you want to stop the code, and you can define the breakpoint and a specific line, and then examine the state at that location. So in PDB, breakpoint are set with the command B or break, and then you should specify the line number that you want to stop. And so, for example, we have a command line here, B, and then the line that we want to have the breakpoint at that line, which is the 8. And this is the output of this command line. which is the breakpoint one at this script, and then the line that we want to have to stop. So for running the script, you need to write C or continue command. So we have C here, and then the PDB start running your code script until the line 8. So for example, at the line 8, we have B is equal to 3, and then we have a stop here. By default, PDB pauses at the start of the execution. And once you type C, it will run until the first breakpoint that you defined before that. So if you want to view some variables at the breakpoint, how we can do that? So by command line P or print, you can view the value of each variable at the breakpoint. So for example, here we have a breakpoint at line 8, and the line 8 is the B is equal to 3. But we have some other variables at this location, which is one of them is A, and we want to know what is the value of A at this location. So we just need to have this command, which is the P, and then the name of the variable, and then the output is 2, which means that the value of the A is 2 at this location. So you also have you can have conditional breakpoint. The conditional breakpoint can be useful in the for loops, for example. For example, you have a for loop where I as start from 0 up to 10, and you want to know the value of variables at I is equal to 5. So you should have a condition here in the for loop so you can do that by just writing this command B and the line number as the before that we mentioned. And we have a comma here, and then we have a condition that is, if it's true, then we have a breakpoint on that line. So let's see an example of the conditional breakpoints. We defined a breakpoint at line 15, and then we have a condition which is that I is equal to 5. And we write this command, which is the C, which means that continue on the breakpoint. And in line 50, we have a if condition, which is if I is equal to 9, and this can continue until the I is equal to 5. So if the condition is true, means that the I is equal to 5, we have a breakpoint. So after generating this breakpoint means that the value of I is equal to 5. And if you want to make sure, you just need to write this command, which is the print I, and then output should be 5, because if we don't have the breakpoint at this line, which means that this condition is not true. But because we already get this we are stopped at this line, means that this condition is true, and then the value of I should be equal to 5, right? So another other useful command line in PDB are step and next and until. So these are useful when you want to stepping through the code. But this means that you have a breakpoint at one line, and you want to know what is the value of variables in the next line, right? So you just need to have a command line next or n that will advance the code to the next line in the current scope. And the step also can do the same thing, but the difference between the step and the next is that the next will not enter function calls, but step will enter function calls. For example, you have a line code which is equal y is equal to square root function, and then passing some inputs to that. So in this case, you want to go to, if you want to go to the lines in the function, you just need to use a step or a command line. But if you want to know, if you want to go to the next line of the code, not in the call function, you can use n or next. Another useful command is the until command. Will run the code until the specified line. And this can obviously continue on this line. For example, if you have until 20, the program continue running on line 20. So these are some useful hints for debugging code in Python that I want to mention. And there is another topic, which is the exception. Actually, exception are a kind of error that happen in a runtime. For example, you have a code and you run the code and you will get a runtime error. This means that your code is generating an exception. And by default, this exception crash your code. And there are many cases where we might want to keep running. One of them is the continuous code, which means that, for example, in a one server application, you want to get a password from the user, and then after getting that password, the program needs to continue. So another one is that restart algorithm with a new initialization, or you want to get some input from the user. So in these cases, we want to keep running the code. And if we get this error at the running up code, we are actually raising an exception. So the Python, the Python have a try except rules in something like if or else, something like this, that allows us to recover from an error. For example, you have try and then code that might have errors, but you have another condition is that except, which means that you are expecting that your code generates some bugs or errors when you are running this part of your code. So you're saying to the computer that try to run this part of your code, but if you get the error, you can run this part of this code, right? So Python will try to run the code in the try block, and if it fails, it will run the code in the except block. So an example of this, you try to divide some numbers by other numbers in the first block. And you already know that you cannot divide some numbers by 0. So in this case, you are expecting getting error when the input or user input is 0. So in this case, you need to handle this error in the except block. And also you can have a condition over except block. And so, for example, if you or you want to handle different exception in different ways. So at the first you have a try block, and then you have an exception for the type 1, and you have some codes here. You have exception type 2, and you have some code here. And finally, you can have a general exception at the end to handle all other things that can happen, but they are not from the exception type 1 or the exception type 2. And I think I show an example of this try exception here. Yes. For example, you have a try exception here, and you want to print the 1 divided by 0. So in this case, we are expecting that this print generate an error. So in the computer tried to run this line of the code, but if the computer cannot run this part of the code, actually it generates an exception which is saying something that we want to say to the user. So there are some common built-in exception types in the Python, which is the value error, which means that if you are getting a value from the user and you are expecting that the value should be between 0 and 100. So if you are getting other values, you just need to generate a value error in exception. There are other types, for example, arithmetic error or input-output error. Also, the Python can allows you to raise your own exception, which means that you want to provide some information about their for the user. For example, you expect that the user enter values in some range. If you are not getting that, you need just to provide this information to the user to actually fix the value of the input. And actually allows the person using your code to handle the exception gracefully. And actually sometimes you have some code and you forget to handle all the ways your code can fail. So in this case, you just need to have a try except block and then try to handle this type of error in your exception part of your code. So raising exception in Python is easy. For example, you can use the keyword raise in your program and then call a function that you want to generate the exception. For example, value error So this can get a string that you want to show to the user. You cannot invert a singular matrix. So you can use this type of built-in exception in Raise. Actually, these exception types are classes, which means that you can get an instance from them. For example, when you code through an exception, you can assume that this exception is an object. For example, here we have try, and then in the try you are trying to print 1 divided by 0, and then except you generate an instance from 0 division error as another name that we just get, and then try to print the error that we get from this object, from this class, which is the 0 division error. So this means that you can also create your own exception classes. For example, as usual, you just need enter class keyword and then the name of the class and then exception. We have a constructor that gets self as usual, and then another import another parameter, which is the n, and we have another actually feature for the class, which is the self.message, and the message that we want to show to the user, and try to divide this number by 0, and then we get the value of the n that we are getting from the input. So later we have some we assign I is equal to 10 and j is equal to 0. And we mentioned that if j is equal to 0, raise this exception, which we define here, and else print I divided by j. So because we are passing I as an input to this exception constructor, and I is equal to 10. So raise means that we are printing the message that we have in this exception. And actually raise print this line, which is the try to divide 10 by 0, because the value of the I is equal to 10, and I is equal to n, and n is equal to 10 because I is equal to 10. And finally, we can have another condition on try exception, actually, which is the finally. So sometimes there is a code that you want to run regardless of whether there was an error or not. And after writing the block for the try and then the exception, you can have another additional block, which is the finally, and always run this code, which means that if we get the error or we didn't get the error, the finally always run. For example, as a simple example, if you are trying to divide one number by 0, and you are printing the value of this division. So in the try block, you have printing I divided by j, and if the j is equal to 0, we are getting the exception or error. So in the exception, we are printing that the j is equal to 0. And finally, we are just saying that the value of the first argument, which is the I. So if we are getting the error or we are not getting error based on the value of the j, we are just printing the value of the I. So exception handling is not just for exception, and actually try except blocks can be used for many things besides handling error. One of them is to try to assigning the value of the key value in the dictionary or dealing the value of that. For example, consider that we have an empty dictionary here, and we are accessing to the key as a actually member of the dictionary, right? If we don't have this, members in the dictionary, we cannot append the another numbers to these members, right? Because we already know that we don't have these members in the dictionary. So if we already have that, the try block try to append these values also to these members. But if we don't have, we just need to expect the key error and then assign assign this list to these members. This means that the members is not already in the dictionary, and you want to just generate that based on the first value that we are appending to the list of this key. And a useful information that the Python can generate is the stack traces, and which means that if you have some codes and you're generating an error inside a function, the Python generate a stack trace for you to find the location of the error. And actually, this stack trace show you a sequence of active function calls, and this start from the high level until the low level in your program that generate the code that generate the error. And let's see an example of that. I think that would be useful. For example, here I define a function which is the my matrix multiply, and then I get x and y, and I just return np dot x and y, right? So after defining the function, I assigning value for the x and y, which are two matrices. The first one is the dimension of the first one is the 1/2, and the second one also is the 1/2. And then I call my matrix multiply by passing x and y, and I try to print that, right? So I get this error, and this is the stack trace that Python generated for us. And in a high level code, the Python say that I try to run line 23 in this script, and then print the line that this line, and then this line of the code actually generate another line, which is the call function, which has another line in actually my matrix multiply. And this means that the Python tried to run this line, which is 98, and then this line also is the return function, right? And after that, the Python tried to run a specific line in dot function in the NumPy, and then generate an error based on the input of the my matrix multiply. And the error is that the shapes 1, 2, and 1, 2 not.
Which means that the numpy dot cannot generate, cannot multiply to metrics with the same dimension. For example, if the dimension of the first one is the 1/2, the second one should be 2 by something, right? So in this case, we are getting this error for value error, which means that the value of the inputs are not true based on np dot function. So as you can see, when your code hits an error inside the function here, inside the np dot, it will print out a stack trace. The stack trace show you a sequence of the active function calls that I show in here, that at the first we call this function, then we call this function, and then in the np dot function we get error. And the stack trace starts with the highest level, the first function you called in your top level script, which means that in this example, we call my matrix multiply, and ends with the exact function that throw the error, and then print the error here. This function generates the exact error, and the error is that the shapes are not aligned. Also, this can be useful for finding the location of the error that I mentioned, which is in important step in debugging. So you can use this information to find the location of the bug, and then after finding the location of the bug, you need to understand that and then solve that. How you can do that? In most cases, if you just print this line of the code in the Google, there are some other links from Stack Overflow, which other people get same error, and then they have some solution for that. So you just need to print this line of the code in the Stack Overflow to find the solution for that. But if you didn't find that, maybe you can ask other people, or if you can find a line of the code that you suspect that about the logic of the code, you can solve that also by yourself. That's the end of this lecture, and I have a demo session in this Friday about the debugging, and that's it. Thanks and bye.